Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்க. எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
And dipole moment is the vector quantity, and in first video I explained, and examples we can discuss. AB2 type. For example, AB2 type, if you take H2O, water molecule is polar or non-polar? The water molecule is polar. Why? Because if you take the structure of water, hydrogen, here also hydrogen, here is one lone pair and here is one lone pair. Now atom to lone pair, what is the dipole moment? Like here is less electronegative to more electronegative. Here also atom to lone pair. Now here is hydrogen and oxygen. Which one is more electronegative? Oxygen. That's why here also atom to, and here also. Now resultant dipole moment is like this. Now mu net not equal to 0, that molecule will be polar. Water molecule is the polar molecule. If you take a dimethyl ether, in this also here is two lone pairs are present. Here is carbon to oxygen. This is a dipole moment, and this one direction also in this from less electronegative to more electronegative. For this one also like this. Now resultant will be like this. Now the mu net not equal to 0, this molecule will be polar. These are the AB2 type of molecules. In AB2 CO2, and if you take SO2, S double bond O, here also S double bond O, one lone pair is present. Now I am taking, which one is the more electronegative? And oxygen is the more electronegative. That's why here is from sulfur to oxygen, here also sulfur to oxygen, less electronegative to more electronegative. But here is the dipole moment from sulfur to atom to a lone pair. Now mu net not is equal to 0, this molecule will be polar. These are the AB type of molecules. First I am taking H2O. In this H2O, if you taking H2O, here is hydrogen, here also hydrogen, less electronegative to more electronegative, here also less electronegative to more electronegative, but the resultant is this direction. That's why mu net not equal to 0, molecule will be polar. And if you take dimethyl ether also, mu net not equal to 0, this is methyl, this is oxygen. Because oxygen is more electronegative, what is the direction I told? Less electronegative to more electronegative. Now carbon to oxygen, now resultant will be this direction. It is also not equal to 0. Now SO2 I am taking, this one is the polar, because if you take a sulfur to atom to lone pair, this is in this direction is going, this is this direction. Now the resultant, the mu net not is equal to 0, because sulfur, oxygen, sulfur, selenium, tellurium, and electronegativity sulfur, oxygen to sulfur, oxygen only more electronegative, that's why it is not cancelling. Next, AB3 type molecules, we can check it. AB3 type means BF3, BCl3, BBr3. AB3 type, write down AB3 type. In this type we can take example BF3 and BBr3 and BI3. These are the examples of AB3 type. Even take SO3 also, AB3 SO3 also. We can take first one is BF3. This one is boron. Here is one fluorine. Here also one fluorine. And in this one fluorine. Now boron and fluorine, which one is more electronegative? Fluorine is more electronegative. What is the direction from less electronegative to more electronegative? Here also less electronegative to more electronegative. Now this direction, which direction? In this direction, fluorine to, actually this is the direction, in less electronegativity is boron and more electronegativity is fluorine. But the resultant for this one, these two resultant, if these two resultant with this direction. Now this direction one and vector and this direction one vector. Now mu net is equal to 0. This molecule will be non-polar. This molecule will be non-polar. Understand? Here is two resultant vectors, this direction and this direction. One is this direction is going, another one is this direction. The resultant will be like this. That's why, and opposite vectors are cancelling each other. The dipole moment is 0. If you take Bi3 or SO3, if you take SO3 also, that is similar structure of BF3 also. In this also, the direction from less electronegative to more electronegative. Here also less electronegative to more electronegative. Now the resultant of these two, this direction and this one is above direction and cancelling each other. Now mu net is equal to 0. That molecule will be non-polar. This will be non-polar. If you take Bi3 or BBr3 also, if I am taking Br, here also Br bromine, here also taking bromine. Now what is the dipole moment from less electronegative to more electronegative, from this to this direction? Now here boron to bromine, here also boron to bromine. Now this one is the one direction, it's going on this direction, and these two resultant will be like this direction. One is above and opposite each other. Now mu net is equal to 0. This molecule will be non-polar, right? Non-polar molecule. Not polar. This is non-polar. Mu net resultant, that is 0, that is non-polar. Here also non-polar, and this molecule also non-polar. If you take AB3 type, understand AB3 type. Now SO2 and SO3, what is the reason? Which one is polar, which one is non-polar? SO3 is non-polar and SO2 is polar, because in SO2 lone pair is present. If lone pair is present, the dipole moment is not equal to 0. This molecule will be polar, but SO3 is non-polar. Why non-polar? It is similar to BF3. Remember, in examination they given SO2 and SO3. SO2 is the polar molecule, mu net not equal to 0. SO3 is a non-polar, because here lone pair is present in SO2. For a BBr3, understand students, because this bromine, this is boron to bromine, from less electronegative to more electronegative, that's mu net is equal to 0. These are the examples of AB3 type. If you take AB4 type, we can discuss. And another point, already the symmetry is present, surrounding atoms are same, symmetry is present and surrounding atoms are same, and no lone pair is present. That is dipole moment equal to 0. If lone pair is present, the dipole moment is not equal to 0. Now AB4 we can discuss. AB4. Now I am taking AB4, methane and CCl4, carbon tetrachloride. Another one, carbon tetrachloride, we can discuss methane and CCl4. In this methane, hydrogen, hydrogen, here also hydrogen, hydrogen. This is the tetrahedral. The dipole moment is one side only, na? The tetrahedral. Now this one, and less electronegative to more electronegative. Like this also we can write it. Now mu net is equal to 0. Why mu net is equal to 0? Symmetry is present, tetrahedral, and surrounding atoms are same. Symmetry is present, symmetry, and surrounding atoms are same. Surrounding atoms are same, and no lone pair is present. That's why these are the reason we can write the tetrahedral like this also. Tetrahedral. Now which one is the less electronegative? This one is less electronegative. Hydrogen to carbon. Here also hydrogen to carbon. Here also hydrogen to carbon. Here also hydrogen to carbon. Why? The mu net resultant vector is 0 because symmetry and surrounding atoms are same. No lone pair. Mu net is equal to 0. That is molecule will be non-polar. Now methane is non-polar. If you take CCl4, I am taking chlorine, here also chlorine, here also chlorine, and chlorine. Now tell me, this one is polar or non-polar? Now I am check it. Symmetry is present, surrounding atoms are same. Now carbon to chlorine, here also carbon to chlorine. Now carbon to chlorine, here also carbon to chlorine. Here carbon is less electronegative, chlorine is more electronegative. Now mu net is equal to 0. This molecule will be non-polar. Why non-polar? Because symmetry and tetrahedral symmetry and surrounding atoms also same. Surrounding all chlorine is present. Here methane also surrounding atoms are same. Now no lone pair is present. What is the condition? These are the condition with this molecule is non-polar. Mu net is equal to 0. That molecule will be non-polar. This is the AB4 type. If you take AB5 type, I am taking PF5. Now phosphorus I am taking initially phosphorus, and these are the fluorine, here also fluorine, here also fluorine, and similar structures to BF3. BF3 means now phosphorus to fluorine is more electronegative. Here also phosphorus and to fluorine, here is less electronegative. Now these two vectors, the resultant will be like this. This one and this one, they cancelling. After here is one fluorine is present, here is one fluorine. Now here also phosphorus to fluorine, here also phosphorus to fluorine. These two vectors, opposite vectors, are cancelling each other. Now mu net is equal to 0. This molecule will be non-polar. In PF5. These are the example of AB4 and AB5. Understand this one? But the directions is same sides are why this mu net is 0. The condition is symmetry and surrounding atoms are same. No lone pair is present. Here also no lone pair. That's why dipole moment is 0. Understand? You can take example PF5 and methane and CCl4. If you take AB6 type, we can discuss AB6 type. Right, AB6 type. Right, SF6 structure. SF6. Here is fluorine. Here also fluorine. And one fluorine. What is the shape? Octahedral. Now this dipole moment is like this. Now sulfur to fluorine. Here also sulfur to fluorine, and this one opposite directions are cancelling each other. If this direction, this one only this direction, this one cancel. If this one is this direction and this one also this direction, opposite vectors are cancelling. Here also fluorine to sulfur to fluorine, here also sulfur to fluorine. Now dipole moments are 0. Now tell me, mu net is equal to 0. This molecule will be non-polar. This molecule will be non-polar. These are the example of AB6. But xenon F2, I am taking xenon F2 and xenon F4. Xenon F2 and xenon F4, these molecules are non-polar. Even lone pair also present. Even in xenon compounds, even xenon F2, particularly xenon F2, xenon F4, if lone pair also present, but dipole moment is 0. We can write the structure xenon F2. First I am writing xenon F. These are the two bond pairs are present. Now here xenon to fluorine, here also xenon to fluorine. Opposite direction vectors are cancelled. After here one lone pair is present, here another lone pair, here also another lone pair. That is similar to here is this direction, this one is in this direction, this one is in this direction. These two resultant will be like this direction, and now this one and this one is cancelled. Now mu net is equal to 0. This molecule will be non-polar. This molecule will be non-polar. If you take xenon F4 means I am taking here is fluorine and fluorine structure, write down. Here also fluorine, here is one fluorine, here also one fluorine, here is one lone pair, here also one lone pair, square planar. Now atom to lone pair this direction, now atom to lone pair in this direction. These directions, this is the above direction, this is below direction, opposite directions, vectors are cancelled. Now here is fluorine, xenon to fluorine, here also xenon to fluorine. These are opposite, they are cancelling. Now here also xenon to fluorine, they are cancelling. Here also xenon to fluorine, opposite vectors. Now xenon, less electronegative, more electronegative. This is the opposite directions, they are cancelled. Opposite directions are cancelled, the vectors, you know. And this direction and another one also this direction, they are cancelling each other. If you take one of this direction, another one also in this direction, these opposite directions also cancelling each other. These are the AB6 type. Example is SF6, that one is the non-polar. Here also xenon F4, even lone pairs also present. Mu net is equal to 0. This molecule will be non-polar. This molecule will be non-polar. Remember AB2 type, AB3 type and AB4 type. Mu net is equal to 0. This molecule will be non-polar. Write the example xenon F2 and xenon F4. But xenon F2 and xenon F4, even lone pair also present, that molecule will be non-polar. These are the examples. If you give one question and tell the answer. NF3 and NH3, which dipole moment? The question, NH3 and NF3, which one is a more dipole moment? Question, more dipole moment. Which one is more dipole moment? Dipole moment. Here which one is more dipole moment means first write the structure of NH3. This is the pyramidal. Here is one hydrogen, here also one hydrogen, here also another hydrogen. Now nitrogen to hydrogen, less electronegative to more electronegative, less electronegative. This is in this direction. No, wrong. Because we are writing less electronegative means hydrogen. Less electronegative is hydrogen, means hydrogen to nitrogen. Here also hydrogen to nitrogen. Here also hydrogen to nitrogen. Less electronegative to more electronegative. And this one is in this direction. Now resultant will be in this direction is going. That's why mu net of NH3 is more in one direction is going. If you taking NF3, here is fluorine, here also one fluorine. Now tell me which one is more electronegative? Fluorine is more electronegative. Now Now in this direction is happening, in this direction less electronegative, more electronegative, all are opposite directions. That's why now mu net dipole moment, which one is more means NH3 is more. NH3 is more compared to NF3. Why sir? Means here is different directions, the dipole moment is less. Here is one direction only going. That's why NH3 is the more dipole moment. In examination they are asking NH3, NF3, which one is the more dipole moment? NH3 is more dipole moment. Please remember this question. Next one is we can take another example, and dipole moment is inversely proportional to theta, the angle. Why? Because I am taking here dichloro 1,2 dichlorobenzene. Next one is 1,3 dichlorobenzene. Next one is 1,4 dichlorobenzene. Here is what is the angle is present? Angle is this one is 60 degree. From this angle is 120 degree, and now this angle is 180 degree. Now theta increases means angle increases means dipole moments decreases. Which one is more? Now ortho is more dipole moment, then para, and this one meta. Meta means this one 1,2 dichloro. We can write 1,2 dichlorobenzene. This one is more dipole moment after this one. Least one is para, because here is cancelling each other. Cancelling each other. In benzene is the planar molecule. All carbons unplane. It is opposite vectors are cancelling each other. Mu is inversely proportional to theta. Remember that one. Now resultant also we can explain NH3, NF3. NH3 is the more dipole moment. In this case, remember mu inversely proportional to 1 by theta. Theta increases means mu decreases. Now theta value 60 for this one 1,2 dichlorobenzene. 1, 2, 3. 1, 3 dichlorobenzene. 1, 4. 1, 2, 3, 4. 1 and 4 position. This because opposite vectors are cancelling in 180 degrees 0. Which one is more dipole moment? 1, 2 dichlorobenzene. Remember this one. If you take, I am taking A, B and AC. The two polar bonds AB and AC are the polar bonds. So two polar bonds, that is one is mu1, another one is mu2. Now mu resultant that is equal to it can be inclined the angle theta. Inclined angle theta. Mu resultant is equal to under root mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. This is the formula we can calculate the mu resultant dipole moment. Simple. AB and AC. These are the two polar bonds. The two polar bonds inclined at angle theta. Theta is the angle. Now mu resultant is equal to mu1 square under root mu1 square plus mu2 square 2 mu1 mu2 cos theta. These are the examples. We can take another question. And cis and trans. Which one is more dipole moment? Cis and trans. If you take a cis structure, cis is the more dipole moment compared to trans. Because I am taking C double bond C, here is chlorine and here is chlorine, hydrogen, here also hydrogen. Now dipole moment from less electronegative means here is carbon to chlorine, here also carbon to chlorine. From hydrogen to carbon, less electronegative to more electronegative, here also less electronegative, more electronegative. This is the in this direction, this one also in this direction. Now mu net not is equal to 0. This molecule will be polar, cis will be polar. Cis is the polar and trans is non-polar. Non-polar, opposites. If you take C double bond C, here is chlorine, here also chlorine, here is one hydrogen, here also one hydrogen. Now dipole moment from less electronegative to more electronegative. Here also less electronegative to more electronegative. Their opposite direction vectors are cancelling. Here also. Now mu net is equal to 0. Now trans is non-polar molecule. Non-polar molecules. These are the examples of the dipole moment. Now here is AB and AC, two polar bonds, mu1 and mu2. These are inclined at angle theta. Now mu resultant is equal to under root mu1 square plus mu2 square 2 mu1 mu2 cos theta. And if you take a cis and trans, which one is more dipole moment? Cis is more dipole moment compared to trans. Trans is opposite direction, that will be cancelling each other. That will be non-polar. If you take another examples, we can take more examples of dipole moment. If you take a CH3 Cl and CH2Cl2 and CH3F and CH2F2, these all molecules are polar molecules. These all molecules are polar molecules. Why? Because polar molecules, here is a dipole moment mu net not is equal to 0. This molecule will be polar. CH3Cl and CH3F, CH2Cl2, CH2F2. Another one is the diatomic molecules H2, Cl2, F2 and Br2 and I2, O2. These type of molecules, the dipole moment mu net is equal to 0. That molecule will be non-polar. These are the non-polar molecule. Next question, if you take the benzene 1,4 dichlorobenzene, if you take chlorobenzene, next one is cyclohexane 1,4 dichlorocyclohexane. Next one is CH2Cl and CH2Cl. This one is the cis compound. And which one is the polar molecule, which one is the non-polar molecule? In this 1,4 dichlorobenzene, all carbon atoms are same plane. That's why the dipole moments are opposite to each other. Here is mu net is equal to 0. This molecule will be non-polar. Why non-polar? Because in benzene all carbons are present in plane. That's why one of the direction is this one, another one is opposite direction. They are cancelling. Here only from this direction. Now mu net not is equal to 0. This molecule will be polar. Next in cyclohexane, the structure is different in cyclohexane. This is the cyclohexane structure. The all carbons are a different plane. That's why, for example, chlorine in one carbon 2, 3, 4. Here is a different places are present. This is axial and this one is equatorial. That's why this is also non-planar molecule. Now mu net not equal to 0. This molecule will be polar. If I am giving cis compound, cis means same side. Now mu net not equal to 0. This molecule will be polar. If any molecule is given, symmetry is present, surrounding atoms are same and no lone pair is present, the dipole moment is 0. And these are the important points about dipole moment. And please share and comment it. And all the best your preparation for NEET 2023 exam.